Hi, I'm Rich Woods from High Performance Consultants. We supply fuel systems and technical expertise for the high performance enthusiast. I'd like to tell you about a new concept we have which will help you understand the theories and principles behind properly assembling an engine. There is more to building a true performance engine than simply bolting together parts. It requires a working knowledge on each individual component works and how they work as a combination. This videotape is just one of a series of tapes designed to answer the most frequently asked questions concerning high-performance engines. And to answer these questions is George Striegel. George is one of the most respected engine builders in the industry, with a background of circle racing, drag racing, and dirt track racing.
In the past 25 years in the camshaft business, not only designing but manufacturing, we have found that one of the most common questions ever asked was, how do you degree a camshaft? What we feel is one of the most important things about installing a camshaft correctly to piston travel in a motor. Now, before we get into the actual degreeing of the camshaft, I think it's very important for whoever to buy a camshaft or install it gets a little idea about what a camshaft actually is. I have a camshaft duplicate right here of what we have installed in this engine. This camshaft is designed and manufactured a little different than a stock camshaft. It's a higher performance camshaft, which means it has more lift and more duration. Now we'll get over here and I'll show you a little bit on the board. This camshaft is identically the same camshaft as we have in the engine that we're going to be showing you how to degree later on. Now right at this present time we're going to show you a little bit about how a camshaft is made. Now the camshaft has a few important parts that should be checked in any camshaft before installed, no matter whether it's a stock or a high performance camshaft. This drawing right here, which we have made, will give you an idea of the camshaft itself on the side. This camshaft lobe is theoretically this lobe right here. A lot of people think this is flat across here. This is cut on a radius. Now the radius of the camshaft is, when it rotates, is what rotates the lifter. The lifter is cut on a radius itself in order that it will ride across the camshaft lobe and rotate it so everything gets correct oiling. Now this camshaft lobe, in the type of camshaft we've designed, we've put the larger amount of taper to the back to hold the camshaft in the rear position of the engine at all times. Now in order to check this at home or at your shop at any time, it's a very easy process. You take a mic, which we have here, we put it on the lobe. We check opposite the lift of the lobe, we check the diameter of the front part of the lobe itself versus the diameter of the rear part of the lobe itself. Now this camshaft mic's about 5 thousandths difference. It's 5 thousandths on the bigger, on the back side, which is very sufficient for the rotation of the lobe of the lifter itself. Once you've determined that, you know that the camshaft is ground right, so you won't have no problem of no rotation and scuffing the lifter, losing a lobe or something. Then we'll go back here to explain a little bit about the camshaft itself. Okay, now this drawing here shows an exhaust lobe and intake lobe and the Lobe Center Method, which we're going to go into in degreeing the camshaft. Now if you were looking at the camshaft in this position, the lobe center is from the exhaust to the intake on a one given cylinder. Now this would happen to be number 1 cylinder, which is every other lobe, and number 2 cylinder on the other side would be these two lobes here. Now in installing the camshaft in the engine, which we will get into in the lobe center, we will show you how to determine where the lobe centers are in the engine on any given camshaft, and we'll explain to you how to install it on the right lobe center, the way it's supposed to be, so the opening and closing is exactly like it's supposed to be. This is a drawing of the bottom of a lifter, which we have found that's one question that we've been asked numerous times about the little pit in the bottom of the lifter. Now this little pit is very important. It's the Rockwell test mark that's in the bottom of the lifter. This is the personal assurance that that lifter has been checked and is found to be 100% compatible with the camshaft material. Most all camshafts have to be very compatible with the lifter, or the one or the other will wear out. The closer the Rockwell is together, the longer longevity the camshaft will have. We have installed the camshaft in this engine already. This camshaft has been lubed properly with the camshaft lube that comes with most camshafts when you purchase them. Some factory camshafts you buy from the dealer do not include cam lube. Now we recommend buying the proper cam lube from the dealer or from one of the camshaft manufacturing companies and lubing the camshaft up to help the break-in procedure of the camshaft before the oil gets up there and supplies the lubrication to stop from any camshaft failures or anything. Now we have installed a timing chain exactly like this timing chain combination. This is not a factory timing chain. This is a high-performance timing chain combination. This has 3 different keyways cut in it. It has a 0 keyway, which is supposedly the straight up and down or the split overlap position. It has an R, which is the retarded position. It has an A, which is the advanced position. Now we're going to install this, and we recommend installing for the starting of a camshaft to green application in the 0 position. Now when you put the key on the 0, that means you align with the 0. If you put the key on the A, you would align with the A. If you put the key on the R, you would align with the R. We have installed this timing combination in this engine with the camshaft on the 0 position with the 2 zeros aligned. I have put an arrow on here, an arrow there to show you which 2 marks you align, and the X represents where we're going to put the key on the crankshaft. Now that we have it installed, we have already installed the degree wheel on the engine. Now the engine, putting the degree wheel on, we want to make it positive top dead center on number 1 piston. Now we have already installed this and we have it set, but we're going to go through the procedures to show you exactly. Now we have a dial indicator on the number 1 piston. We bring the number 1 piston to the highest possible point of movement. We zero the indicator, which we have right there. Now this can also be done with a piston stop, which is a piece of material that would bolt across the top, and you would bring the piston till it stopped one direction, mark your degree wheel. You'd go around completely the other way till it stopped, mark your degree wheel. Halfway in the center would be positive top dead center. Now we have brought it up to the top. Well, the piston stays at top dead center for a few degrees, so we have to make sure we're on positive top dead center. So to do this, we will go down on the dial indicator 50 thousandths, one direction. It doesn't matter left or right. We'll go down 50 thousandths until we're right at 50, and we'll stop. Now we'll look at the pointer on the degree wheel. You'll see that it's at 12.5 degrees from TD center, from top dead center, that direction. Now we'll write that down, 12.5, just for my own reference so I don't forget it. Now I'll go back to the 0 and go down 50 thousandths the other side of the lobe. 50 thousandths perfectly. We look down there and we see that it's on perfect 12.5 degrees. So we know that we're on a positive top dead center to start with. The reason we have decided to use the dial indicator for finding positive top dead center on the engine rather than the piston stop method is that this happens to be a small block Chevrolet engine. This type of degreeing process can be used on any type of motor, from a Ford to a Chrysler to a Datsun to a Volkswagen, and a dial indicator will work on any application to where it would require a different type of piston stop for every type of engine, also every type of piston configuration. Now we're going to start in the process of degreeing the camshaft on the Lobe Center Method. Now the first thing that's required is at least one solid lifter. We'll put 2 solid lifters in the number 1 cylinder. Now it doesn't matter whether you have a hydraulic camshaft or a solid lifter camshaft. We recommend using a solid lifter type to check it with. The fact is, if you use a hydraulic lifter, if you go down into the center, the plunger might move on you, go up or down if it's not compressed up to the top like it's supposed to be. Now it is possible to use a hydraulic lifter and use the outside edge for your dial indicator, but it makes it a little more difficult to do it. It's better if you have a solid lifter around to do it with. Now we're going to put a lifter into each one of the intake, or the exhaust and the intake lobe of the number 1 cylinder. which on this engine happens to be the farthest cylinder forward, which is the number 1 cylinder over here. Now, I've already checked these lifters for the Rockwell mark on the bottom, the radius ground. They look very well. Although we're only using them for checking, this is one thing that it's a good thing to check when you get ready to install your lifters in on your camshaft. Now, we're going to put the lifters in the holes. Make sure they're lubed up good and everything will move freely so that they'll go follow the camshaft up and down. Then we'll install the dial indicator on the surface of the block here. It's a magnetic base, so it will stay there like it's supposed to. Then, to determine, we're going to use the number 1 intake lobe first. So determine to make sure you're on the number 1 intake lobe, we'll put our wrench on the front of the motor. All 4-cycle motors go exhaust intake. So if you hold your 2 fingers on the lifter, rotate the engine in direction, you'll see this finger went up first, that's the exhaust. This one comes up, the intake. We go around again, exhaust, intake. So we know that the second cylinder back is the intake lobe. Now we are going to use a push rod, which happens to be a ball and cup push rod, to operate the dial indicator off of the lifter itself. Now, as I said before, we can operate the dial indicator off of the lifter itself, down below, off of any type of a mechanism that'll drive it, a rod, a piece of wire. People have used a lot, but we're using this push rod. I think is going to probably work better than anything right now. We'll install this on the lift in the center of the dial indicator and in the center of the push rod. Make sure it's all centered and good. Now we're on the number 1 intake lobe. We're going to turn the engine over until we get to the highest possible point of that lobe. Once we get to the top of the lobe, we're going to zero the indicator on the top of the lobe, on the number 1 intake lobe, which we're on right now. Now we're going to find out where the center of the number 1 intake lobe is. We're up on the center of the lobe right now. So we're going to go back down 50 thousandths on the indicator travel. It makes no difference left or right. We're going to start one direction. We're going to go down 50 thousandths. Watching the indicator, watching the lifter go down 50 thousandths on the lobe. Right to 50. Now we're going to look at our degree wheel and we're going to see where it is from the TDC point. It is reading 61 degrees. We're going to write this number down on the board, 61. Now we're going to go back and we're going to bring this dial indicator right back up to the top of the lobe. We're going to continue 50 thousandths down the other side of the lobe, which we have done. We stopped right at 50. We're going to go down and count how many degrees from TDC it is again down there. This happens to be 157 degrees. We're going to write this number down, 157. Now we're going to add those two numbers together, which is 218 added together. Now to find the lobe center, the center of those two numbers, we divide that in half by 2. And half by 2 says that this is in at 109 degrees is the number 1 intake lobe. Now we know what this camshaft is, but not everybody knows what the camshaft is going to be. So we're going to show you how to determine what the camshaft is before you degree it. Now we have moved over to the number 1 exhaust lobe. We have the indicators, push rod set up on the indicator, and we're going back up to the top of the lobe again, the highest possible point, and we're going to zero our indicator. Okay, we have it perfectly on 0. Now we're going to do the same as we did on the intake. We're going to go down 50 thousandths. And we're going to take our reading on our pointer from TDC. We're at 155. Write that number down, 155. Okay, now we're going to go back up to the top of the lobe again, and we're going to go down the other side of the lobe. Exactly 50 thousandths till it stops. Looking down at our our degree wheel, we're going to read how many degrees it is, and it is 59 degrees. 59 degrees. We'll write 59 degrees down. Now we're going to do the same as we did on the intake. This is the number 1 exhaust. We're going to add the two numbers together. Okay, that's 214. We're going to divide it by 2, the same as we did on the intake. Comes out to 107. It shows us that the intake is in at 109, the exhaust is in at 107. Now we're going to determine exactly what the camshaft is ground on, what lobe center degree. By determining this, we will add the first intake number, which is 109, the exhaust number, which is 107, add them together. We come out with a total of 216. Now to determine the lobe center of the camshaft, we will divide it by 2 again. We will come out at 108. Now, we know that we have a 108 degree camshaft. The intake is in at 109. The exhaust is in at 107. Now we know that the camshaft is in the engine. We do not even know what lift it is, what duration it is, what overlap. We know nothing, except we know the camshaft is 108 degree lobe center. It is in 1 degree retarded. The larger the numbers on the intake are retarded, the smaller the numbers are advanced. Otherwise, we know we have a 108 degree camshaft. If we came up with a number of the intake, say 110, that would be 2 degrees retard. If we came up with a number on the intake of, say, 106, would be 2 degrees advanced. Smaller the numbers advance, larger the numbers retard on the intake. On number 1 intake. Lobe. Smaller numbers advance. And just always remember that. The smaller the numbers from the lobe center is advanced, the larger the numbers from the lobe center is retarded. Now, in order to compensate to get this camshaft back to split overlap, it would take a 1 degree offset bushing in the gear, the top gear, to compensate for the 1 degree to get it back to where we move this back to 108. This would automatically become 108. This would be a perfect installation, or what we call split overlap. Now that we've determined the camshaft, exactly what it is, and we've determined that the number 1 intake lobe is in at 109 degrees, and it is a 108 degree lobe center, we automatically know that the camshaft is in 1 degree retarded, which I've written over here on the board. Now we're going to show you how to compensate to get the camshaft back to exactly 108 degrees, or what we call split overlap, or straight up and down insulation in the motor. First, it requires removing the timing gear combination from the top. Of the engine. Now, I always recommend putting the degree wheel on your perfect 0, so that if you move something around, you know it isn't still lined up, you know you've changed something. You have to go back and double check your TDC mark again. So we'll take this gear out. Now you use a 13/32 drill bit in order to drill out the gear to accept the advanced retard bushing. Now this one main thing about doing this gear and drilling it for the bushing is a very important thing not to forget. A lot of people do it. They drill completely through the gear. And when they do this, it allows the bushing, if anything ever came loose, to pop out and would let your camshaft go either backwards or forward. Bushing could get inside of your motor and cause a lot of damage. Now, in order to drill this like you do, you be very careful. You go down to the point to where you do not go completely through, but you go in deep enough to accept the bushing in the gear without going completely through. You notice this side looks like it's not been drilled. This side is the size of the bushing. Now the bushing has a fat side and a thin side on it. These bushings come in two different types of packages. They have a bushing set, which are 1, 3, 5, 7, and 9, which are the odd degree ones, and they have even degree ones, which are 2, 4, 6, and 8. You determine this to where your camshaft is. Naturally, this one here, we want a 1 degree button. We're going to try to move the camshaft 1 degree back up to 108 at perfect split overlap. Now, we've already drilled this gear out to accept this bushing. Now, in order to make sure you put the bushing in the right direction, you remember advancing the camshaft, we would be turning the engine to the rotation, like this. So the fat part of the camshaft bushing would go to the top for advance. Now, to retard the camshaft, we'll be turning the camshaft back away from crankshaft rotation, so the fat part of the bushing would go down. Knowing that we're going to advance this camshaft 1 degree, we're going to make sure we put the fat part of the bushing to the up position on the gear itself. So we put this in. Now, the 13/32 drill bit makes it a nice tight fit in there, so you put your bushing in. Requires just slightly tapping it, position it into place. Once you have it into place, you can sit and you look and make sure that your fat part of your bushing is straight up in parallel. Once you've determined that, you're ready to put your gear back on the engine again. Now we'll reinstall the gear on the engine itself. Okay, now we have this gear marked to where the center points are easy to see again like we had before. Now, the main thing is you're still going back with your 2 zeros lined up like you had before. Now we know that the engine's on TDC as it is. We look down and inside here. We put our marks positively lined up like they were before. We put our bolts back in. Now that we've tightened up the bolts on the camshaft, we'll check back down and make sure our marks are still aligned like the factory marks are aligned right. We'll come up back here and we'll completely go through the process we did again to double check the offset in the bushing that we put in there to make sure that the 1 degree is actually 1 degree. Now we'll go back up to the top of the lobe again. Center our indicator, which is already centered. Now we'll go down 50 thousandths one way. Take a reading on our wheel, which is right on 60 degrees. We'll go back up to the top of the lobe again. We'll go down 50 thousandths the other direction. Now we'll take a reading on our degree wheel. It's at 156. Now we'll add those two numbers together. Just 216. Now remember to find the center of the lobe. We divide it by 2, which gives us 108 degrees. Now that puts us at perfect split overlap. That's split overlap or straight up and down. Now that's exactly, to put the camshaft in straight up and down is how you would do it. We were lucky the 1 degree bushing came out exactly 1 degree and it put the camshaft in perfect. So we have the number 1 intake at 108. We know the number 1 exhaust is hooked right to the same camshaft, so we know that it's going to move the 1 degree and it's going to be at 108 perfectly too. We've installed this camshaft on the split overlap method, or straight up and down, exactly the way the camshaft was ground. Intake at 108 and the exhaust at 108. Now this is not necessarily how you would install every camshaft. It depends on how the manufacturer's recommendation would be, or how the application that the camshaft is going to be used for. Depending if you need more bottom end horsepower, then you would naturally advance your camshaft. If you need more mid-range and top, you might retard it a little bit. Now, we're going to get back into a very important part that we neglected to show you. Now, we have just tightened these bolts on the end of the camshaft temporarily to check our bushing to make sure everything's right. Now, one very important thing to do, we do not want this camshaft to move at any time from where we put it in. So we want to take each one of these bolts out one at a time, apply Loctite, put them in and tighten them to the factory specifications. Now I'm going to show you another way to double check yourself on the cam real quickly here. Now we use 50 thousandths checking down both sides of the lobe first. Now we're going to go back and check them 35 thousandths down each side of the lobe, just to double check ourselves before we quit, to make sure that we haven't messed up on a number or something. Now that is perfectly on 68. We're going to write this number down, 68. Okay, we're going to go back up to the top of the lobe again. We're going to go down 35 thousandths again. Okay, it is exactly on 148. Now as you can see here, we're going to total these up again. The numbers changed, the total remained the same. We're going to divide them by 2. It come out to exactly 108. Now you can use two different points of checking yourself, double checking yourself like we did there. I do not recommend going down any more than 50 thousandths, because you get into the accelerating opening side ramps and the decelerating closed sides of the ramp. But if you go 50 thousandths each side of the nose, you're going to be on the nose area of the camshaft, which remains an even arc. Now, going less than 50 thousandths is good. You could double check yourself at 25 thousandths, 40 thousandths, whatever. But we always start at the 50, and I just arbitrarily go back to 35 thousandths to double check myself. I come out with the same number twice, I know I'm right. I don't have to worry about it. I can close it up after that. Now that we've showed you the complete way to do it on the Lobe Center method of degreeing the camshaft, which we feel is the most accurate way and the best way to determine what the camshaft is, we're going to show you a couple other little methods here that are sometimes come on timing cards from different cam manufacturers. Some cam manufacturers recommend degreeing the camshaft on what we call the 50 thousandths checking clearance, which is 50 thousandths from the heel up. They give you a 50 thousandths opening reading, and they tell you just to put the camshaft in at that reading. It's so many degrees before top dead center at 50 thousandths, and the camshaft will be installed right. Now, I don't really feel that this is a very accurate way to degree the camshaft, because at the 50 thousandths lift rate, you're at the max rate of lift of the camshaft. Just 1 degree could, 1,000ths a dial indicator reading at that point could put you a lot of degrees off. Or the base circle running out a little bit, not starting in what the manufacturer calls the bottom part of the base circle. Camshaft being bent a little bit could maybe put the base circle out 2 or 3,000, could put you quite a few degrees out. Now I'm going to just run through this quickly and show you how it's done. Now we're on the number 1 intake lobe like we were before. But basically, instead of going to the top of the lobe, which we did on the Lobe Center method, we're going to the heel, the farthest travel down, which we are now. Now we're going to zero the indicator. The indicator is zeroed on the heel. Now, we're going to do exactly the same way we did on the camshaft when we did the Lobe Center method, except we're starting on the bottom of the lobe, or the heel of the camshaft. Now we're turning the engine over until the lifter runs up 50 thousandths. Okay, at 50 thousandths, we're going to look down on your degree wheel. Your degree wheel reads 20 degrees before TDC. We're going to write 20 degrees down. Now that would be the opening figure. If your cam card said put the camshaft at 20 degrees at 050 lifter rise, then this would be installed correctly, which it is. It's going to come out. Now we're going to continue up to the top of the lobe, which we find that this camshaft lobe is at the peak at 345 thousandths. We're going to continue down the other side of the lobe. Remember, we are passing 180 degrees now. We're going down the other side of the lobe. Now we went down to make sure we were on the last rotation. We're going to go back. We're going to stop at 50 thousandths just before we get down to the other side of the lobe. Now at 50 thousandths, remember we opened at 20 before. We went all the way 180 degrees. So we're going to add 180 onto this 20. Now we're going to count from 180 to where the pointer is now. We've gone 10, 20, 30, 40, 50, 6 degrees. So we're going to add 56 degrees on it. Okay, now we know that this camshaft is 256 degrees at 50 thousandths. Now some manufacturers give you a 50 thousandths degree reading to give you an idea of the rate of lift of the camshaft. Now this camshaft is at 256 degrees at 50. Now to make sure that it's installed like it should be installed on the thing, what we do is we divide this 256 in half again, which would 256 by 2, 128 is what half of that is. Now remember, we're going half because the crankshaft turns twice the amount of the camshaft because of the ratio. Now you've got 128. So now we'll subtract our lobe center, which we know is 108 from that. So we have an opening of exactly 20, exactly where it is installed. So we know that we put it in exactly right at the 50 thousandths reading. Now we know that the 50 thousandths checking is where we want it to be and everything looks good. We're going to get into actually checking the timing card that you got with the camshaft, or if you didn't get a timing card and it's a factory camshaft, we're going to see what type of actual working clearance it does have and what the overlap looks like. Now this camshaft has a 24 thousandths valve adjustment, which comes on the cam card, which you will see in any of the cam manufacturers that you buy your camshaft from. Will tell you the correct valve adjustment to set it on. Now this happens to be a small block Chevrolet, and it is a 1.5 rocker ratio. So we know that the valve adjustment is 24 thousandths. We have to cut that down by 1.5, which will give us a checking clearance of 16 thousandths. Otherwise, the slack ramp or the adjusting ramp on the camshaft is 16 thousandths long. Now the camshaft lobe would look similar to this. Now this is kind of exaggerated here, but this is what we call the base circle. The circle in which the camshaft keeps the lifter in a stationary position. Now this part of the camshaft lobe is the adjusting ramp or the slack ramp. It's the ramp that's designed to take the slack out of the valve train. The distance between the lifter and the bottom of the push rod, the top of the push rod and the rocker and the valve. If this just came up to a quick rate of lift, it would bend things, break things, or things would wear out very drastically quicker than they do now. So once we know this slack ramp, that's how valve adjustment is determined. This slack ramp is 16 thousandths long from here to here. That means that the valve adjustment's 1.5 rocker ratio. 1.5 times that would come up with your 24 thousandths valve adjustment up at the valve. Now we've determined that we have the 16 thousandths adjusting ramp on the camshaft or the slack ramp. Now generally we want to get a little breakdown here. This is the heel area from the time the valve or the lifter returns and is in a stationary position till it comes around to the slack ramp to start the opening rate. And that's the heel or the base circle of the camshaft. Now this part here, up to the nose area, right in this area where it starts to get into the circle type of deal, is what we call the opening ramp. Okay, this ramp here is up till it starts to decelerate the valve train and become into the even nose area, which is over to here. This is the nose area. Now just these things are basically what cam manufacturers, some cam cards give you, and we're going to give you an idea of what it is. Now when you come back here, this is the quick acceleration part of the deceleration of the ramp there, and this is what is considered the closing ramp. Now you'll get here and you'll have your same 16 thousandths area here, but instead of taking the slack out of it, it returns the lifter back to the base area or the heel area, slow, and slows the acceleration down of the lifter so it just doesn't bounce a few times down here. It's almost the opposite of the ramp over here, but it slows it down so it'll stay on the base circle, come around to the adjustment ramp or the slack ramp again, and start its cycle over again. Now we're at the point to where we can check out the cam card or determine exactly what the working duration is of the camshaft at valve adjustment if we don't know. You know, say we bought this with a factory camshaft and they gave you a factory card that says set the valve at 18,000, but you don't know exactly what the duration is or the overlap. So what we're going to do is we're going to check. We know that it's 16 thousandth at the cam, 24 thousandth the valve, so we're going to come down here. We're going to take our wrench and we're going to make sure that the camshaft is directly at the bottom of the heel again, and set our indicator, which is already set again. Now we're going to go in rotation of the engine up to the 16 thousandths. Okay, we're on 16,000. Now we're going to read how many degrees that is before top dead center, and it's 47 degrees. We're going to write our 47 down. Okay, now we're going to continue to the top of the lobe, watching our indicator, watch it go up. Now remember, we're passing 0. So we're watching, our lobe is still going, lifter's still going up. Now we've passed the 180, so we've got to write that 180 degrees down. Now we're going to watch our indicator, take it back down to the 16. Okay, that's 0. We'll back it up and we'll go right back down to the 16. We're on the 16. Now we're going to see how many degrees it was past the 180. 10, 20, 30, 40, 50, 60, 70, 80, 2. Now we add them all together. Okay, now we know that the camshaft has an actual working duration of 309 degrees. And it has a 50 thousandths reading of what we figured when we did the 50 thousandths checking. So we know exactly what the camshaft is. Now, some camshafts are not what we call equal profile. They have a different intake lobe and a different exhaust lobe. The way to check it, we know this camshaft's the same intake and exhaust, so it's not necessary for us to check it, we already know it, but in the application of not knowing the camshaft, you would just go over to the exhaust lobe, the number 1 exhaust lobe, and duplicate what we did on the intake, just exactly, and it will tell you exactly what the exhaust is, too. Now that we've concluded and figured out the exact working duration of the camshaft, there's one other thing left to do that's very important, is to check the actual lift of the camshaft and the valve. By knowing this, we have to determine this to make sure that we don't have a problem with springs, coil binding, or anything in the valve train causing your problem, valve to piston or anything that could destroy the motor very quickly. Now, every time you put an aftermarket camshaft in an engine, this is a very important thing to think about. Factory springs in any application, whether it's Chevrolet, Ford, General Motors of any type, even foreign Datsuns or any of them, they have a certain amount of coil bind that will allow the factory camshaft to go into it. But when you put a larger lift camshaft in it, sometimes you have to change to a different spring combination just to allow for the extra lift of the camshaft so that everything just doesn't come together and break something. Now what we're going to do here is we're going to do the same thing we did when we were checking the exact working duration of the camshaft. We're going to center our indicator on the heel of the camshaft, which has already been done when we were using it before. Now we're going to go around and we're going to watch the indicator. Now the indicator's starting to lift there. We're going to turn it slow to watch how many times it goes around. This is the 100,000th indicator, so it's went around once, 2, 3, 46. So we know the cam lobe lifts 346 thousandths. Okay, we know we have a 1.5 rocker ratio. So we multiply the cam lift by 1.5. Okay, now we know that the cam has a gross lift, which we call gross lift. Now, almost all cam manufacturers put gross lift on the cam card. This allows, if you have any problems with valve to piston or anything, and you have the pistons cut while you're waiting for the camshaft and they tell you the gross lift, we know that you'll have at least enough clearance for it, because you're going to actually have a little more gross lift than you will actual valve lift. Now we know that the camshaft has a 24 thousandths valve adjustment. And that's the slack between it. So we know that we're going to lose 24 thousandths of this through the valve adjustment. So we subtract the 24 thousandths from it, which gives us an actual valve lift of 495. Now that tells you exactly how far the valve is actually open. That's after the valve adjustment, after everything. That's what the valve, if the rocker ratio is actually right. Now, when they give you a rocker ratio of 1.5, generally that's what the factory says the rocker ratio is. Sometimes it requires a little bit of rocker geometry work to get that exact ratio. Generally, they're never more than 1.5. Generally, they're less than 1.5 unless you ratio the rockers or get special length push rods to get the ratio and the geometry back exactly like it's supposed to be. But by figuring it this way, you'll know exactly what it could have at the maximum amount of lift. So if you figure your push rod length, you figure your valve pocket in your piston, you figure your coil bind in your springs when you're setting up your heads for that amount, you know that you're not going to get yourself in trouble. I'll just refresh a little bit and trying to explain why we thought the Lobe Center Method was the best. I think by watching what we've done, I think you'll understand why we think the Lobe Center Method is the most accurate way to degree the camshaft. We showed you how to check it at 50 thousandths, how to make sure your 50 thousandths reading is where it's supposed to be, the opening side, how to check your actual duration, how to figure your lift on your camshaft, how to do the basic things and the most unknown basic things that we have the most questions about for the last, I would say, 20 years or 25 years I've been in business. Now there's a couple other little things that we didn't dwell too much on that I'd like to talk to you about. Now the main thing is when you install the camshaft, you want to make sure that you don't destroy your camshaft bearings as you're putting it in. We use a couple of long bolts on the front of the camshaft in which we try to support the camshaft a little better when you're going to push it into the last journal. This way you just aren't trying to hold this and push it in, you're holding it like that and pushing it in. Another main thing is lubing the camshaft up very good. Now all cam manufacturers put cam lube in with the camshaft itself. This camshaft lube is designed to put on the lobes mixed with oil to lube up everything good for the initial break-in of the camshaft. Now the camshaft only gets oil from the oil being thrown out between the rods and what's running down from the top of the engine. So if you let your engine sit there and idle very slowly, it's not going to get any lubrication like it should. Some camshaft manufacturers recommend running the engine at 2,000 RPM for 20 minutes. I don't think that's necessary. I just think it's necessary to rev the engine up a little bit every once in a while to get oil up to it and to make sure that the right amount of oils up to the cam and lifters to allow it to break in, also to the cylinder walls on a new engine. It's very important to get oil up on the cylinder walls to seat the rings and things. You don't sit and let your engine idle for a long time after a camshaft installation or an engine rebuild. You just run it long enough to make sure you have no leaks or nothing else, and then go out and run it and break the motor in. Now that probably does it just about as far as the lube goes. You want to make sure everything's lubed up good as far as the lifters and the bottom of the camshaft. Now another important thing which we mentioned was the camshaft bolts. I've seen a lot of people go through the degreeing of the camshaft and be taking the bolts in and out and forget at the last time to put them in for the final time and lock them in. We recommend using red Loctite, putting the camshaft bolt in, torque them down, double check them, make sure they're tight, because if they come loose any time during the life of that motor, the valves would get into the piston. Anything changes the timing between the number one piston and the valves is immediately a way to destroy an engine very fast. Now another thing that you want to do when you're putting the engine back together after degreeing the camshaft before the head's put in, when you put your timing cover on and you put your harmonic balancer on, you put your dial indicator back on the number one piston and make positive that the 0 and the pointer on your timing mark is exactly right, lined up right, so that your engine can be timed exactly right with the timing light when it's put together, so that not only by degreeing the camshaft that the timing is correct, and if you have the jetting right, the engine's going to perform and work exactly like it's supposed to be done. This equipment that you've seen we've used here in degreeing the camshaft and checking it out is available from HPC. It will include the degree wheel, what you see, the pointer, the 1-inch magnetic base dial indicator setup. It'll have a ball and cup push rod. It'll have 2 lifters to your type of engine that you have, solid lifters, which will come along in the kit for further use. Now all you have to do to order this is to order it directly from HPC, and send the type of engine that you have, and just ask for the cam degreeing kit.
I'm sure you found this videotape helpful and easy to follow. If you have any other questions regarding high-performance engines, remember, we're only a phone call away.